Now let us look at what? The nucleus and some of its property. Nucleus of an atom. So this is the spherical central part of an atom. Of what? An atom which consists of proton and neutron. So the nucleus can be found at the center of an atom that is comprised of what? Of proton and neutron. That is what we call what? The what? Nucleus. And what do we need now is what? We need nuclear charge. Sorry, is nuclear mass. What is nuclear mass? Nuclear mass is the total number of proton and what? Neutron in the nucleus of what? An atom. Nuclear mass is the total number of proton and neutron in the nucleus of what? Of an atom. That is, mathematically, we call it what? Assume a what? Assume nuclear what? Mass. It should be what? Number of proton plus number, sorry, assume nuclear what? Mass be what? Number of what? Of proton plus number of what? Neutron. Can I say what? Assume nucleus or nuclear what? Mass. And assume nuclear what? Mass will be equal to the what? Mass of proton plus what? Mass of what? Of neutron. But why what? Real nuclear mass is less than mass of what? Neutron, total number of mass of what? Neutron plus mass of what? Proton. In the nucleus of what? Of an atom. The assumed nuclear mass. But the mass defect, the what? Mass what? Defect or change in what? In mass. Call it what? Mass defect. Defect, which is what? Change in M, would be equal to the what? This nuclear mass, mass of proton plus mass of neutron minus real nuclear mass. That is the mass defect equal to the what? the mass what? Defect will be mass of proton plus mass of neutron minus real nuclear mass. See, in short, nuclear mass simply means what? The total number of what? Proton and neutron in nucleus of an atom. And the mass defect of an element can be determined by the what? By mass spectrometer. By what? Mass what? Spectrometer. What? Meter. So by any mass spectrometer, we have assuming mass is the total number of proton and neutron in nucleus of atom. The real mass less than what? The assuming mass. So to know the what? The mass defect of the nucleus, it will now be what? Real mass, the assuming mass minus real what? Real mass. We will apply this when we get to the what? To the bonding energy calculation under nuclear reaction. So fusion and fission. So yes, the next thing that we need now here is what? Need what we call what? Isotope, isobar, or no, isobar and isotone. So let me start from the word what? Isotope. What is isotope? So this isotope, this is a what? That exists between two or more atoms of the same elements, have the same, have what? The same atomic number, but different mass number. What is isotope? It exists between two or more atoms of the same element. They have the same atomic number, but different what? Mass number. What are the examples of isotopic elements? One, we have hydrogen, one, one, hydrogen, one, two, we have hydrogen, one, three. Look at this hydrogen. This one you have here, they are called atomic number. Here we have one, two, three. This is atom of the same element, hydrogen. They have the same atomic number. Their mass number here is what? Is differ. If you still remember under atomic what? Theory. So if you are writing elements in this form, if element S is this one is called what? Atomic number. This one is what? Mass number. So this atomic number is one, but their mass number is what? Difference. Hydrogen, protium, deuterium, and tritium. So the phenomenon between these three elements is called what? Isotope. They have the same atomic number but different mass number. We can also have it in what? Carbon 612. We also have carbon 613, and we have carbon 6 for what? 14. Carbon 612, carbon 613, and carbon 6 what? 14. The same atomic number but different what? Mass what? Mass number. They are atom of the same element, carbon. Atomic number 6, mass number 12, 13, 14. That is what? What? Isotope. Or you can also have it in what? In example 3, we have oxygen 6, 8. We have oxygen 6, oxygen 8, 16. We have oxygen 8, 17. And we have oxygen 8, what? 19. So look at this oxygen 2. It's undergo what? What we call what? Isotope. We can also have it in example 4, chlorine 1735 and chlorine 1737. Look at this one. This hydrogen here, tritium. This hydrogen we have here is a radioactive what? Let me give you one example more. We also have uranium what? Uranium. We have uranium is what? Uranium 235, 90, and uranium 92. Sorry, uranium 90, 92, 235, 235, and 238. So it's also what? Isotope. Phenomenon that exist between two or more what? Atom of the same element but different atomic number is called what? Isotope. And the next thing we have what we call what? Isobar. We have what we call what? Isobar. We have Isobar. This isobar, this is occur between two or more atoms of different elements having the same mass number, have the same what? Mass number, but different atomic what? Number. Look at isotope here. They have the same atomic number, but different what? Mass number. But here, the same what? Mass number, but different atomic what? Number. Example of isotope elements we have. Example, one, we have nitrogen 714 and carbon 714. Look at the carbon and nitrogen here. They are atoms of different elements. but their atomic number are the same, 77. Mass number are atomic number is 6. Atomic number are different, but the mass number are what? Are the same. The atomic number are what? Are different, but the mass number are what? Are the same. That is for what? Iso what? Example 2, we have potassium 1940 and calcium 2040. There's no need for you to cram. If they want to test for it, they will just give you this. What is the phenomenon between what? Nitrogen 714 and carbon 614? Atom of different elements, but they have the same mass number, different atomic number. But in isotope, the same mass atomic number, but different mass number. But isobar, the same mass number, different atomic number. That's it. So calcium and potassium, they have 40-40 here, but the atomic number are different and element also was different. So that is what? How to identify them. The last one is isotone. Isotone simply means what? It is occur between two or more atoms. Isotone. This is what? It is occur between two or more atoms of different elements. Elements have the same neutron number, but different atomic and mass number. So this isobar, the atomic number are the same. Isotope, this mass isotope, atomic number are the same. Isobar, mass number are the same. Isotone, number of neutron are what? Are the same. Example of isotone, examples of isotones. One, we have one hydrogen 3 and what? Helium 2, 4. Look at these two atoms. This is hydrogen, this is helium. Atom of different what? Elements. But atomic number difference, mass number difference. What is number of neutron? Subtract 1 from 3, we have 2. 2 from 4, we have 2. They have the same number of what? Of neutron. So we can also have this nitrogen 714 and carbon 613. Atomic number different, mass number different. Subtract this from this 7. From this 7. These are the what? Isotone. So thank God we have understand what we call isotope, isobar, and isotone. The next thing that we are going to treat now is what? Unstable isotope and a stable isotope. So next thing is what? Let us look at what? What we call what? Stable isotope. This stable isotope, they are also called what? Non-radioactive elements. So the stable isotope element, they are also called what? Non-radioactive what? Elements. They are elements with stable nuclei, which cannot emit radiation. They are what? They are elements with stable nuclei, which cannot emit what? Radiation. And they do not undergo radioactive decay. So any element that is about a stable nuclei cannot undergo radioactive what? Decay. So all those elements are called stable all those isotopes are called stable what? Any isotopic element which have what? A stable nuclei and cannot undergo radioactive decay or radioactive emission, cannot produce emission of what? Of radioactive particle. Such particles are called what? Such particles are called non-radioactive elements or stable isotope. So the stable isotope, they are what? They are elements with stable nuclei which cannot emit, which cannot what? Emit radiation. Which cannot emit what? Radiation. And they do what? They do not undergo radioactive decay. Example of the isotope, e.g., we have oxygen, these three oxygen. The only this one is what? Is radioactive isotope. These two, they are what? They are not. Carbon, we have three. The only carbon 614 is a radioactive isotope. The remaining two are what? Are not. E.g., we have carbon what? Carbon 612, and we also have what? Oxygen 816. We also have hydrogen 1, 1, etc. All these elements, they cannot undergo what? Radioactive what? Emission. Spontaneous disintegration cannot what? Occur there. Why? Because their nucleus is what? Is stable. So we can now observe that what? Any any isotope that is have what? Abnormal nucleus, which is what? The nucleus is what? Is not stable, is the only isotope that can undergo what? Radioactive decay or radioactivity. It is spontaneous disintegration of nucleus of what? Of unstable radioactive what? Of isotope. What make the nucleus of the radioactive element unstable? Because they have what? Abnormal neutron. So because depending on what abnormal neutron they have in them, they need to do what? To become stable. As a result of that, they will now transform it to the what? Another element. To the process of transforming to another element, they will form what? They will release radiation, either alpha or beta or gamma particle, accompanied with what? With energy. So, but the next thing is what? Non, oh, sorry, next one is unstable. On what? Unstable iso what? Isotope. The unstable isotope, they are also called what? Radioactive elements. So, what is what? Unstable radioactive elements. They are what? Is opposite of this. They are elements with unstable, you know what? Unstable nuclei. What make the nucleus of what? Of this radioactive element unstable? Due to presence of what? Abnormal neutron. Close the bracket. Due to the what? The presence of what? The large number of what? Of neutron, because of abnormal neutron, which release, which can release or which can emit the what? Radiation. And the element can undergo radioactive what? Decay. That's what? They can undergo what? Undergo radioactive active what? Decay. And any element, any radioactive what? Or any element that have what? Unstable nucleus are called radioactive what? Elements. And their nucleus is what? Is not stable. So because of the have what? Unstable nucleus, they need to what? To become stable. That is major reason why make them to what? To release what? Radiation. Why is it that what? The radioactive element emits radiation? The radioactive element, they are unstable, they have unstable nucleus. In order to make their nucleus to be stable, they need to what? To form another, to transform to the another element. If they transform to another element, they will now release what? Radiation. By the show of that, they will now become what? Stable. An example of what? E.g. of this element, example of this element, examples of radioactive what? Radioactive elements are one, we have uranium, which is what? U. We have radium, radium, which is what? Ra. We have radium, we have radon, radon, which is what? Rn. We have polonium, polonium, which is what? Po. And the last one we have thorium. Thorium is what? Th. These are the common radioactive elements. These are the elements that is have what? The unstable what? Unstable nucleus. What make them have unstable nucleus? Because they have what? The abnormal what? Neutron. Take for instance now, by checking this one, okay, this 6 minus 7, neutron here, 6 minus 10 minus 6 minus 12. The neutron number here is what? Is 7. 8 minus this, 16. Neutron number here is what? Is 8. 1 minus 1. Neutron number here is 0. But look at what? Uranium. For uranium, 92235. Abi, subtract this 9235 from this. Look at what? The number of neutron you have here is what? Is much. Is abnormal. So that's why make people get what? Radioactive what? Radioactive elements. They have large number of what? Of neutron. So any element that is about the large number of what? Of neutron, that element is what? Is radioactive what? Element. So the next thing that is what we are going to treat now is what? Is nuclear decay. So we are done with what? Radioactivities. Don't forget that what? We are in nuclear chemistry, study of nuclear reaction. The reaction that involving what? Proton and neutron is called nuclear chemistry. which is known as what? Nuclear reaction. I now said from the beginning of the class, the nuclear reaction comprised of four processes. We have radioactivity, we have radioactive decay, we have nuclear fission, and we have nuclear what? Nuclear fission, and we have nuclear fusion. The next thing now is what? Is the radioactive decay. Let us look at what? Radioactive decay. How do what? Radioactive can be decay to alpha, beta, and the gamma. After that, we now check what? Nuclear fusion and nuclear fission. From there, we now move to the what? Radiokinetic, kinematics of radioactivities. Now we're talking about half-life of the calculating aspect.